Okay, dear student, let's see what is there in this question. A system of moment of inertia I rotates from rest about a given axis. The angular acceleration alpha of the system is constant. What is the change in angular momentum when a system has made 4 complete rotations? Okay, this is a very difficult question. I would say immense. Couple of reasons. Number one, like this topic of inertia, the rotational body, earlier in the old syllabus it was the part of optional engineering physics options, and so not every student was going to do this. It was not in your regular syllabus, but this time this topic has been added into your new syllabus. So there you are, you find the moment of inertia in IB's paper 1 kind of questions first time, and on it the question is not easy because they are mixing too many things. Like they're talking about the moment of inertia, at the same time talking about alpha, and it is also given it is constant. They're talking about angular momentum on it, and on it they're talking about the angular displacement. There are many variables which have to be connected with each other. So I suppose this should be one of the most difficult question in this question paper. So let's see how to do this question. So my method of doing these kind of question is, first of all, think about, rather than thinking about the rotational dynamics, we would be thinking about the translational motion and think what kind of formulas would you be using if it was translational. And then we think about what is the corresponding formula in the circular motion. That is how you think. So the moment of inertia is actually replaced with m. Acceleration is written with a, and it is given as acceleration is constant. Now it clearly makes sense. Why is it given that acceleration is constant? Something should be related with Shewhart equations, because otherwise acceleration can have any value. Because it is given acceleration is constant, you would be using the Shewhart equations, equation of motions you can call it. So that is A. Angular momentum is there, so we would be talking about the momentum and the displacement. So clearly displacement has nothing to do here. So if displacement is sitting here and acceleration is constant, some Shewhart equations will be going on between these two variables, and then we would be finding something, and mass will be multiplied to create force and dynamics, and then we will enter into momentum. Okay, so let us think about okay, they're talking about the momentum. So momentum is related with kinetic energy. There is a formula, P square is equal to 2mk. And kinetic energy is connected with one particular Shewhart equation, which is V square minus U square is equal to AS. Till now, I have not talked about the circular motion or rotational motion even once. Now, once I have the complete picture clear to me, I would be talking about circular motion. So let us find the final omega with which it is moving. Initially it is at rest, 2 alpha theta. So this displacement is theta. Displacement is given as 4 times the complete revolution. It means 4 times 2 pi. So it will be 8 pi. So theta can be substituted as 8 pi. Yes, because it is 4 times 2 pi, so it will be 8 pi. This is omega square. So it is 16 alpha pi, which is omega square. Now I want to find the kinetic energy. Now in this case, if we were talking about the translational kinetic energy and translational momentum, but now I want to talk about rotational kinetic energy. So rotational kinetic energy is given as half I omega square. So I just multiply half I here to make it kinetic energy. Similarly, the same will be multiplied on the other side also, because it is the principle of algebra. This and this gets cancelled out. It will become 8. So this is coming out to be 8 alpha pi into I. This is the kinetic energy. But this kinetic energy can be written as P square by 2m, which in the terms of rotational variables, P can be written as L and m can be written as I. So I would be just substituting it here like this, and I solve it. So L square, this 2 goes here, 16 alpha pi I square. Now you take the square root on both sides, so L will be equal to 4 alpha pi, sorry, alpha pi will be under the square root, 4 I alpha pi square root. So this should be the correct answer. L is equal to 4I root of pi alpha. So this is how we do this. All the best. Bye.